Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Welcome to new chapter, which is chapter 2, application of vector calculus. In chapter 2 there are three subtopics, which is Green's theorem, Stokes theorem, and also Gauss theorem. In this chapter we will apply what we have learned in chapter 1, for example, single integral, double integral, also triple integral. So in this video, let's start with subtopic 2.1, Green's theorem. For definition, let's see the simply connected piecewise move closed curve with a counterclockwise orientation located on two-dimensional plane region R. Okay, two-dimensional means it occurs in two planes, which is occurs on XY plane only. Okay, the curve have to be simply connected piecewise smooth closed curve. As you can see here, we have different curve C1, C2 and C3, where we call it piecewise curve. Okay. C1, C2 and C3 is three different curves, but it is connected and closed region. Green's theorem states the relationship between a line integral, which is line integral C1, line integral C2, line integral C3, and a double integral over a simply connected plane region R. Okay, you also can see here the arrow. The arrow here is counterclockwise. Counterclockwise. Okay, so to apply Green theorem, the double integral over the region is equal to the line integral around the region of counterclockwise orientation, which means it positive orientation. So, like I have mentioned just now, to apply Green's theorem, the curve C must simply connected piecewise closed curve with a counterclockwise orientation located on 2D plane region R, which occurs in XY plane only. Next, let f equal to pxy, qxy, where p and q have continuous first partial derivative, then the Green's theorem is defined as the line integral p dx plus q dy is equal to surface integral del q over del x minus del p over del y dA. So we can state here the relationship between line integral and surface integral. So here the left hand side is line integral and right hand side is surface integral. Okay, single integral we apply. The single integral here we apply line integral, and double integral here we apply surface integral. Okay, you can see here at the left hand side with single integration, you can see C here, means it is a curve, and this notation like circle here is, which means closed curve. Okay. Other than that, this notation means curve C satisfies the condition of Green's theorem, which first it is curve C is connected, closed curve. Condition number 2 is have positive orientation, which means it is counterclockwise. Counterclockwise orientation. So for Green's theorem, instead using line integral, you also can calculate double integral, which is surface integral, to find Green's theorem. Let's move to step to solve Green's theorem. Okay, first step, you need to sketch the region. Okay, second step, you need to refer to the question. Okay, in Green's theorem, there are two types of question. Okay, first, if the question asks you to verify or prove the Green's theorem, then you must calculate both sides, left hand side here and right hand side. You must to prove that left hand side is equal to right hand side. Okay, second question, if the question asks you to evaluate the Green's theorem or use the theorem, you have to calculate one side only. Okay, for example, the question asks you to evaluate line integral p dx plus q dy, which is left hand side. So you must to show the answer in right hand side. Show right hand side. Okay. If the question gives us the right hand side, you must show left hand side. Let's see example 1. Show that the Green's theorem is verified for single integral curve C xy plus y squared dx plus x squared dy, where C is bounded by y equal to x and y equal to x squared. Okay, sketch the curve C. Okay, let's start with step number 1, which is sketch the curve. So you have to remember, when you do Green's theorem, it only occurs in xy plane. So you can sketch, this is x, this is y. So the equation gives you y equal to x and y equal to x squared. Okay, let's start with y equal to x. Okay, what is y equal to x looks like? It is a straight line. Straight line that intersect x equal to 0 and y equal to 0. Okay. Next is y equal to x squared. Y equal to x squared is a quadratic equation. So the curve is something like this. So this is y equal to x and this is y equal to x squared. So you can directly write this is as curve 1 and this is curve 2. Okay, next, you can make an arrow for each curve. This is arrow for C1 and this is arrow for C2. Okay, and you have to remember when you do green theorem, the arrow must counterclockwise. Okay, you also have to make sure that the curve is close each other. And we have label C1 and C2 and the curve is counterclockwise. Okay, next you have to find the intersection point here and here. Okay, how to find the intersection point here? Okay, so you have to do simultaneous equation. Okay, we have y equal to x and y equal to x squared. So you can label it as equation 1 and this is equation 2. So you can substitute 2 in 1. So you will get x equal to x squared. So when you simplify it, you will get x squared minus x equal to 0. So you can factorize this equation, you will get x minus 1 equal to 0. From this, you know that x equal to 0 and x equal to 1. Now, when x equal to 0, y is equal to 0. And from this, we know that when x equal to 0, y equal to 0. Next, when x equal to 1, y is equal to 1. Means that we have two intersection points which is 0, 0 and 1, 1. So this point is 0, 0 and this point is 1, 1. Okay, step number 2, you have to refer to the question. Okay, the question asks you to verify. So when the question asks you to verify, you have to show or calculate both sides. Okay, left hand side and right hand side. Okay, as you know, this is the formula for Green's theorem. So this is the left hand side and this is the right hand side. Okay, I will start to solve left hand side. Okay, p dx plus q dy. So this is the single integral and which is line integral. So we have to solve both curves. So here we have two curves C1 and C2. Remember what you have learned in line integral in subtopic 1.5. Okay, I will start with curve 1, which is C1, y equal to x squared. Okay, remember, first step to solve line integral, you need to parameterize the equation. Okay, you have to parameterize y equal to x squared. So you can see on your textbook, table 2.3, you have to use other curve. So when you use other curve, you let x equal to t. So y equal to t squared. And next, you have to substitute in p dx plus q dy. You have
x x is equal to t times y is t squared plus y squared is t squared dt, sorry, dx. So dx here is equal to dt, and dy is equal to 2t dt. So dx is equal to dt plus x squared is t squared, dy is equal to 2t dt. When you simplify it, you will get t cubed plus t power of 4 plus 2t cubed dt. So you will get 3t cubed plus t power of 4 dt. Okay, next you need to determine the limit. So you can refer to the figure C1. Okay, remember what you have learned in line integral, how to determine the limit based on the question. Okay, before this, you have parameterized the equation. You take x equal to t. So the limit based on point x. Okay, you can refer to this figure. Okay, the arrow is from this point, which is 0, 0 to this point 1, 1. So the arrow is counterclockwise, so the limit is from 0 to 1. So you can integrate it, you will get 3t power of 4 over 4 plus t power of 5 over 5, limit 0 to 1. So when you substitute 1 and 0, you will get 19 over 20. So this is the line integral for curve 1. So I will continue and in the next slide. Okay, next we proceed to curve 2 C2, which is y equal to x. The same step, you have to parameterize the equation. So x equal to t, so y equal to t. So you will substitute in p dx plus q dy, you will get single integral x is t y t plus t squared dx. So dx is equal to dt. So dx is equal to dt plus x squared, here is t squared, okay, dy is equal to dt. So you simplify it, you will get t squared plus t squared plus t squared dt. So you will get 3t squared dt. So next step, you need to find the limit. For C2, curve for C2 is here from this point to this point. Okay, from point 1, 1 to point 0, 0. Because of the arrow is counterclockwise, so you need to integrate from 1 to 0. So you can integrate this, you will get 3t cubed over 3, limit 1 to 0. So when you substitute 0 and 1, you will get negative 1. So this is the line integral for curve 2. So you just add up C1 and C2, we will get 19 over 20 plus negative 1. So you will get negative 1 over 20. So this is the left hand side. Okay. In the next slide, I will show you step to solve right hand side. Now we are going to solve right hand side. You know that right hand side is equal to double integral del q over del x minus del p over del y dy dx. First of all, you need to know what is p and what is q. Okay, based on the previous step just now, we know that p is equal to xy plus y squared and q equal to x squared. Okay, based on this formula, we need to find del q over del x and del p over del y. Okay, first, we find del p over del y. So you will get x plus 2y, and for del q over del x, you will get 2x. Next, you substitute in this. You get double integral 2x minus x plus 2y dy dx. So when you simplify it, you will get x minus 2y dy dx. Okay. Next step, we need to determine the limit. Okay, how to determine the limit? Okay, based on the figure, we have two curves close to each other. Okay, this is y equal to x, and this is y equal to x squared. Okay. Let me find the limit for dy first. Okay, you can see here we have two curves here. Okay, which curve is below than the other curve? Okay, you can see obviously that y equal to x squared is below y equal to x. So y equal to x squared will become lower limit, and y equal to x is the upper limit. So next, for dx, you have to remember before this we have 2 points, okay, 0, 0 and 1, 1. Okay, to find x, lower limit is the smallest point, which is x equal to 0, and the upper limit is the biggest x, which is x equal to 1. So next step, you can integrate it. Okay, first you integrate respect to dy, you will get xy minus 2y squared over 2 limit x squared x dx. When you substitute x and x squared, you will get x minus x squared minus x times x squared plus x squared squared dx. When you simplify it, you will get x squared minus x squared minus x cubed plus x power of 4 dx. So you integrate respect to dx, you will get negative x power of 4 over 4 plus x power of 5 over 5, limit 0 to 1. So when you substitute 1 and 0, you will get negative 1 over 20. So this is the right hand side. Okay, I will continue in the next slide. In previous slide, we have calculated left hand side to single integral t dx plus q dy is equal to negative 1 over 20, and right hand side equal to double integral del q over del x minus del p over del y dy dx equal to negative 1 over 20. So we have proved that left hand side is equal to right hand side. So you can write here Green's theorem is same. Let's see example 2. Use the Green's theorem for solving single integral x squared plus y squared dx plus x plus 2y dy, which has been evaluated by boundary that defined as x equal to 0, y equal to 0, and x squared plus y squared equal to 4 in the first quarter. First step, you have to sketch the figure. So you have to remember that Green's theorem only occurs in x, y plane. So the question gives you x equal to 0. So this is x equal to 0 and y equal to 0, and also x squared plus y squared equal to 4 is a circle, but the question states that this is in the first quarter. So the circle in the first quarter is like this. So we have closed curve here, so you can write this as the C1, this is C2, and this is C3. So you have to remember that the orientation is in the counterclockwise. So here we have three curves, C1, C2, and C3. I will show step number 2 in next slide. Step number 2, you need to refer to the question. Okay, the question gives us you to use the Green's theorem. And when the question asks you to use, you have to calculate one side only. Okay, which side? Okay, look at the question. Okay, before that, you know that this is the formula for Green's theorem. Okay, the single integral is the left hand side, and this double integral is the right hand side. Okay, look at the question. The question gives you single integral. So the question gives you left hand side. Okay, when the question gives you left hand side, you have to solve the right hand side. Okay. So from the question, we know that P is equal to x squared plus y squared, and Q is x plus 2. Next, you have to find del Q over del x and del P over del y. Okay, first, del P over del y, we will get 2y, and del Q over del x, you will get 1. Okay, therefore, When you substitute in del q over del x minus del c over del y, you will get 1 minus 2y. When you substitute in the formula of double integral del q over del x minus del c over del y, you get 1 minus 2y dA. Okay, what is dA? Okay, I will continue in the next slide. In the previous slide, we have get double integral 1 minus 2y dA. Okay, now we want to find what is dA. Okay, so you can look at the question. The question gives you x squared plus y squared equal to 4, and you know that this is a circle with radius 2. Or you can refer to the figure that we sketched before. We have first quarter of a circle. So when the question is about a circle, you have to use polar coordinate of a circle or polar coordinate of a plane. So you can refer to your textbook. The polar coordinate of plane x equal to r cos theta, y equal to r sin theta, dA is equal to r dr d theta. So next step, you will substitute the polar coordinate. You will get 1 minus 2. Y here is r sin theta. dA is equal to r dr d theta. So you will simplify it. You will get r minus 2r squared sin theta dr d theta. Okay, next step, you need to find the limit of integration. So first you want to integrate respect to dr. So r here is equal to 2. So the limit is from 0 to 2. And for theta, this is a first quarter of circles. So the limit is from 0 to pi over 2. So you can integrate it. First, you integrate respect to r, you will get r squared over 2 minus 2r cubed over 3 sin theta 0 to 2 d theta. So when you substitute 2 and 0, you will get 2 minus 16 over 3 sin theta d theta. So next, you will integrate respect to theta. You will get 2 theta plus 16 over 3 cos theta limit 0 to pi over 2. So when you substitute pi over 2 and 0, you will get pi minus 16 over 3. So this is the final answer. Okay, you don't have to do the other side because the question use the Green's theorem. So you can see Green's theorem is to simplify the solution. Instead, you have to use line integral to solve each curve. Here we have three curves, C1, C2, and C3. Okay, when you use Green's theorem, you can solve one-time integration only. Okay, integration becomes simpler, so it's easier for you. Don't have to integrate three times for to find C1, C2, and C3. Okay, I think that's all for today. So I hope you can understand it. Thank you.